Beneath the Philippines, the Earth is waging a relentless war. Squeezed by the Philippine Sea and Eurasian plates, tangled in a web of hundreds of faults and volcanoes. This isn't just another corner of the Ring of Fire, it's its deadliest. Here, tsunamis can strike in minutes, fault lines run under megacities, and volcanic giants sleep uneasily next to millions. Why is this nation nature's prime target? And how close are we to the next catastrophe? The answer begins with the very ground itself. The Philippines sits in a place geologists call the Mobile Belt, a restless zone squeezed and twisted by some of the world's most powerful tectonic plates. On one side, the Philippine Sea Plate pushes northwest with surprising force, moving at about 6 to 8 centimeters a year. On the other, the Eurasian Plate, also known locally as the Sunda Plate, presses eastward at a slower but relentless pace, about 1 to 2 centimeters per year. These two giants don't just meet, they collide and grind, trapping the islands in between. The result is a tangled patchwork of microplates and crustal blocks, each shifting in its own direction. Animated arrows on scientific maps show this chaos. Thick vectors point from the east and west, their lengths revealing the speed of movement. Smaller arrows crisscross the archipelago, marking regions where the ground is being stretched, squeezed, or sheared sideways. This isn't a simple boundary line. It's a complex, ever-changing zone of compression and deformation, running the entire length of the country. Unlike most places on the Ring of Fire, where a single boundary dominates, the Philippine Mobile Belt endures pressure from both sides. Subduction zones lie offshore, while inland, the crust is sliced by faults and riven by volcanic arcs. The whole region is under constant geological stress, with energy building up in multiple directions at once. This unique geometry explains why the Philippines faces not just frequent earthquakes, but some of the world's most varied and extreme geological hazards, all packed into a narrow, crowded chain of islands. Deep beneath the Philippine archipelago, relentless compression has sculpted one of the most crowded and unstable geological environments on Earth. The Mobile Belt is not just squeezed, it is crumpled, fractured, and riddled with faults. In some regions, geologists have mapped more than a dozen major faults packed into a single province. This density is extraordinary. The Philippine Fault Zone alone stretches over 1,200 kilometers, while dozens of smaller faults splinter off, twisting through the islands in every direction. Each fault is a potential source of disaster, storing energy that can be unleashed with little warning. Compression doesn't just create faults, it also folds the crust, stacking and warping rock layers until they break. This process forms clusters of volcanic arcs and deep ocean trenches, all tightly packed within a narrow corridor. It's rare to find another place on the planet where so many active faults and volcanoes are crowded together in such a small area. The result is a landscape where almost every region sits close to at least one major fault or volcanic system. This extreme clustering means that the ground beneath the Philippines is always under stress, with energy building up along multiple lines of weakness. When one fault slips, it can trigger movement along others, sometimes setting off chains of earthquakes or volcanic unrest. The country records hundreds of felt earthquakes every year, and thousands of smaller tremors go unnoticed except by sensitive instruments. In this compressed and fractured zone, the next major event is not a question of if, but when. Along the west coast of Luzon, the Manila Trench operates as a hidden engine of destruction, quietly storing the energy of converging plates until it snaps. Unlike a single continuous fault, the trench is divided into distinct rupture segments: southern, central, and northern, each capable of producing earthquakes between magnitude 8.4 and 9.2. These are not abstract numbers. A full segment rupture could send a wall of water racing across the South China Sea, with maximum wave heights reaching 10 meters along exposed coastal towns. Synthetic slip models show how the energy release is rarely uniform. Some segments slip more than others, focusing wave energy on certain shorelines. In worst-case scenarios, multi-segment ruptures propagate enormous tsunamis, impacting a broad swath of western Luzon. The difference between a single and multi-segment event is the difference between a damaging surge and a region-wide catastrophe. Arrival times for these tsunamis are brutally short. In places like Zambales, Pangasinan, and Ilocos, the first wave could strike in as little as 2 to 15 minutes after the earthquake. That's less time than it takes to clear most coastal barangays, especially at night or without warning. Models consistently show that Manila Bay, while somewhat shielded, can still face damaging surges in the largest events. A research team at the Philippine Institute of Volcanology and Seismology described the Manila Trench as a loaded gun pointed at densely populated coastlines. Their simulations make it clear. The mechanics of this subduction zone leave precious little time for warning, and the consequences of a full rupture are measured not in hours, but in minutes. In the early hours of August 17th, 1976, darkness still hung over Mindanao's coastline when the earth began to convulse. Offshore, a magnitude 8.1 earthquake ripped open the Cotabato Trench. Within minutes, a wall of water as high as 5 meters crashed into sleeping villages, flattening homes and sweeping entire families out to sea. By sunrise, over 8,000 people were dead or missing. A toll made worse by a simple, brutal fact: no warning had reached the coast. Survivor accounts from the Moro Gulf disaster still haunt disaster planners. One fisherman recalled, "The sea pulled away so fast we thought it was low tide. By the time we understood, the wave was already coming." Hospitals filled with the injured, most never having heard the word tsunami before that night. There were no sirens, no text alerts, and no offshore sensors to catch the first hint of a wave. Nearly 50 years later, the same silent gaps remain along the country's west coast. The Manila Trench, capable of producing tsunamis just as deadly, still lacks a single operational, Deep Sea Detection Buoy. 5 Ulsi and Jika maps reveal wide stretches of coastline, Zambales, Pangasinan, Ilocos, where the only warning comes from shaking underfoot. Models show that in many towns, the first wave could arrive in as little as 2 to 15 minutes. On evacuation charts, that's barely enough time to get out of bed, let alone reach high ground. Despite repeated calls for action, political disputes and funding delays have left the detection network unfinished. The evacuation window remains dangerously narrow. For millions living near the shore, the next tsunami could strike with the same silence as in 1976, leaving only moments to react and no second chances. The Philippine fault zone cuts a jagged scar across the archipelago, running more than 1,200 kilometers from northern Luzon to Mindanao. This is not a single crack, but a system of fractures, slicing through cities, mountains, and farmland alike. Along its length, the ground can shift sideways by meters in a matter of seconds. In 1990, the reality of this threat became undeniable. On July 16th, a magnitude 7.7 earthquake ruptured a segment of the fault near the town of Rizal in Nueva Ecija. The earth tore open along the Digdig Fault, producing a surface displacement of up to 6 meters, enough to offset roads, fences, and even rivers. Intensity maps from Fishivol-Sis show a broad swath of central Luzon shaken at intensity 8 or higher, the kind of ground motion that topples concrete and folds steel. In Baguio City, more than 50 kilometers from the epicenter, hotels and schools collapsed in seconds. Landslides buried entire neighborhoods. Survivors describe a roar like a freight train, the ground heaving so violently that people could not stand. One survivor recalled, "The floor moved like a wave, walls cracked, and the air filled with dust. We ran, but the world kept shaking." Across Luzon, over 1,600 people died and tens of thousands were injured or left homeless. The fault's movement was not hidden underground. It ripped through rice paddies, split highways, and left a jagged step in the earth that remains visible today. The 1990 Luzon earthquake proved that inland faults are not a distant threat. The Philippine fault zone is active and capable of unleashing devastation far from the coast, with shaking strong enough to collapse modern buildings and trigger deadly landslides. The scars from that event serve as a warning. The ground beneath the Philippines is restless, and the next rupture could strike anywhere along this vast fault system. Over 300 volcanoes rise from the Philippine landscape, the silent legacy of a country built atop clashing tectonic plates. Of these, at least 24 are classified as active, each one a potential source of devastation for the communities living in their shadow. The connection is direct. As subduction zones force one plate beneath another, magma forms and rises, fueling the arcs of volcanoes that dot the archipelago. Every generation, this underground process breaks the surface with explosive force. June 1991. Mount Pinatubo, a long, quiet peak in central Luzon, burst to life with one of the most powerful eruptions of the 20th century. The eruption ejected 10 billion tons of magma, ash, and aerosols into the sky, darkening the sun and sending shockwaves around the globe. More than 200,000 people were evacuated from the surrounding provinces, many forced to abandon homes that would soon be buried by ash and mud. The eruption's impact reached far beyond the initial blast. Monsoon rains transformed volcanic debris into deadly lahars, swallowing entire towns like Bacola under meters of mud for years after the eruption. Pinatubo's ash cloud cooled global temperatures, a reminder that Philippine volcanoes can shape not only local lives, but even the world's climate. Mayon volcano, with its near-perfect cone, stands as the country's most active. Over the past 4 centuries, it has erupted more than 50 times. Each episode brings rivers of lava and ash flows racing toward nearby villages, forcing repeated evacuations. For many, displacement is a regular part of life. Families move to temporary shelters, not knowing when they can safely return. The threat is never far away. Even when quiet, Mayon's slopes are closely monitored for signs of unrest. These volcanoes are not isolated hazards. Their eruptions are often triggered or intensified by the same tectonic forces that cause earthquakes. When the ground shakes, magma chambers can destabilize, setting off eruptions or landslides. In the Philippines, the risk is constant and intertwined. The same subduction that drives the faults beneath cities also powers the volcanoes that loom over them. For millions, the ground beneath their feet holds the memory of past eruptions and the promise that more will come. A single line on a hazard map slices through the heart of Metro Manila, tracing a path from Quezon City to Muntinlupa. This is the West Valley Fault, one of the most closely watched fault lines in Southeast Asia. Beneath the city's dense sprawl, the fault is locked and silent. But history and science both agree it will not stay quiet forever. PHIVOLCS estimates that a major earthquake along the West Valley Fault strikes every 400 to 600 years. The last rupture happened over 4 centuries ago. By their own words, Metro Manila now sits squarely within the danger window. The mechanics are unforgiving. The West Valley Fault is a strike-slip fault, capable of producing a magnitude 7.2 earthquake in a matter of seconds. Shake intensity models predict ground motions strong enough to snap bridges, topple high-rises, and rip open roads. The shaking would be most violent in cities built on soft, reclaimed land, Pasig, Marikina, Taguig, where the ground itself can liquefy, swallowing buildings and buckling highways. Metro Manila is one of the most crowded urban areas on Earth, with over 13 million residents packed into a tight basin. PHIVOLCS warns that a full-length rupture could cause tens of thousands of casualties. Their scenario models, developed with JYCA and the National Disaster Risk Reduction and Management Council, project over 48,000 deaths and $48 billion in economic damage if the quake hits at night when most people are indoors. Hospitals, water pumping stations, and power substations all sit within the high shaking zone. More than 5,000 road segments, including EDSA and C5, cross the fault or run parallel to it. Critical arteries that could become impassable in minutes. A structural engineer reviewing recent building surveys points to a stark reality. Many older buildings and informal settlements are not designed to withstand this level of shaking. Even some modern high-rises, built before the latest code, updates, or granted zoning exemptions, could fail. The engineer's assessment is blunt. Many existing structures will collapse. Retrofitting is urgent. Lives hang in the balance. PHIVOLCS does not mince words. Their official bulletins state the West Valley Fault could produce tens of thousands of casualties. The question is not if, but when. For millions living above or beside the fault, the risk is immediate and deeply personal. Liquefaction corridors cut through the heart of Metro Manila, tracing the same low-lying zones that flood every typhoon season. In these districts, a strong earthquake can turn the ground to liquid, swallowing buildings whole. Official hazard maps highlight entire stretches of Pasig, Marikina, and Taguig as high risk, where even modern towers stand on uncertain foundations. The lesson is written in the ruins of Bohol. In 2013, a magnitude 7.2 earthquake struck the island, and neighborhoods built on reclaimed or waterlogged land saw the worst destruction. Homes tilted, roads split, and critical bridges vanished beneath waves of mud. Engineers who inspected the aftermath found that structures built to code or retrofitted in the years after previous disasters survived. Non-compliant buildings, especially those with shallow foundations, collapsed or became uninhabitable. Action is not just a matter of technical fixes. City planners point to a checklist, enforce strict building codes, retrofit hospitals and schools, and relocate families living directly on fault lines or liquefaction zones. The National Disaster Risk Reduction and Management Council estimates that over 100,000 residents in Metro Manila alone need relocation out of high-risk corridors. Yet, relocation efforts face delays, budget shortfalls, legal disputes, and the deep reluctance of families to leave their homes and livelihoods. Funding for retrofitting has been rolled out in phases, but timelines stretch for years. Policy bottlenecks, from permit backlogs to competing priorities between agencies, slow progress further. Typhoons compound the urgency. Every year, storms saturate the ground, weaken buildings, and fill evacuation centers to overflowing. When earthquake and typhoon seasons overlap, the risk multiplies. Rescue routes flood, shelters collapse, and emergency response grinds to a halt. Officials warn that preparedness must adapt. Multi-hazard planning, early warning systems, and public drills tailored for compound disasters, not just single events. The agenda is clear: science-driven zoning, transparent enforcement, and investment in resilient infrastructure. Without these, the next disaster will not just test the country's strength, it will expose its weakest points. The Philippines is the only nation with over 300 volcanoes, 24 of them classified as active, and sits atop a tectonic collision zone where the Philippine Sea Plate and Eurasian Plate meet. This ongoing compression has created one of the world's densest networks of faults and ocean trenches, putting millions in direct risk from earthquakes, tsunamis, and eruptions. Metro Manila, home to over 13 million people, sits above the West Valley Fault, which, according to PHYV-OLCS, is overdue for a magnitude 7+ quake, with potential for tens of thousands of casualties. Despite decades of scientific warnings and government reports, gaps remain. As of 2025, there is no full tsunami detection system installed off the Manila Trench, and many urban buildings do not meet modern safety codes. While the science identifies the hazards and history proves their impact, the timeline for preparedness, especially in the face of compounding threats like typhoons, remains uncertain. The evidence is clear. The Philippines' extreme geology is not just a story of the past, but a challenge for every day that follows.